Hello lovely people, what is up? Today we are solving Leetcode problem number 4, median of two sorted arrays. So in this question we are given two sorted arrays nums1 and nums2 in the size of m and n respectively. So nums1 will be of size m and nums2 will be of size n. We have to return the median of the two sorted arrays. So we have to combine both the arrays and then return the median. The overall runtime complexity should be log of m plus n. This has also been given as a condition. So on first thought, if we use brute force, we can just merge and pick middle, but that's not optimal time. That is not O of m plus n. So what we can do is, instead of merging, we simulate the merge using binary search. So that is pretty intuitive why we are using binary search here. So we split both the arrays into left and right halves such that left has half the elements and right has half the elements. So we want maximum of left should be lesser than or equal to minimum of right. So that is all. So when that condition becomes true, we will know that we have found our median. So what is the base strategy here? We pick a cut in first array and then automatically calculate the cut in the second array. So if we have to check if the partition is valid and then adjust a binary search. Binary search works here because if left side is too big, we move left, and if the left side is too small, we move right. So basically the two conditions that we are checking here is if the left of first array is smaller than or equal to right of the second array, that is the minimum and maximum. The same way, the left of the second array, maximum value of the left of second array should be less than or equal to minimum value of the right array, right of first array. So while we are coding, we first initialize an if statement if len of nums1 is greater than len of nums2, then nums1 comma nums2 equals to nums2 comma nums1, and then we calculate the total length. So total equal to len of nums1 plus len of nums2. Then we calculate the half equal to total flow divided by 2. So and then we initialize left and right. Left comma right equal to 0 comma len of nums1 minus 1. This left and right values we use to search for the correct partition index. And then we start a while loop to keep searching until we find the correct partition. We are guaranteed to find it. So while true, I is equal to parenthesis left plus right flow divided by 2. So this finds the partition index for nums1, middle index A, and this defines split in A. And for partition in B, what we do is j is equal to half minus I minus 2. Why are we doing minus 2? Because I and j are indices and they are not counts, so we are adjusting for zero base indexing. So this ensures left size of A plus right size of B equals to half. And then we get the boundary values. Nums left, so let's name it 1 left, equal to nums1 of I if I greater than equal to 0, else float of inside colons minus infinity minus inf. So this takes care of the boundary values. Left side max of A, if no elements we use negative infinity, and then 1 right is equal to nums of I plus 1 if I plus 1 is lesser than len of nums1, else same float of infinity. We use negative infinity in the uppercase, and then now we are using infinity because this is the right side and we use the minimum. So if no elements, we use the maximum possible value, which is positive infinity. And then we do the same for B. It's just instead of I, we use j. Let me copy paste and correct this. Yeah, so it works. And then we check if the partition is correct. So if 1 left smaller than or equal to 2 right, and 2 left is smaller than equal to 1 right. So this means left side is valid and no elements is out of order. So if partition is correct, we define an if statement. If total divided by mod 2 return minimum of 1 right and 2 right. So return min of 1 right comma 2 right. So median is the first element of the right side. That is why we are returning the minimum value. And then outside the if statement, we return parentheses max of 1 left comma 2 left plus minimum of 1 right comma 2 right divided by 2. So this is the median, average of the largest left value and the smallest right value. So if the partition is wrong, we use elif. Elif 1 left is greater than 2 right, we do right equal to I minus 1. So if we took too many elements from A, we move left in the binary search. And then the else case, if 1 left is too small, we use else. Else left equal to I plus 1. So we need more elements from A, so we move right. And this is all inside while loop. So as you can see, the code is running in the most optimal time complexity possible. So that's all for today. Hope you guys enjoyed today's video. See you in the next one. Bye guys.